when you are looking at graphing a function, probably the easiest way to do that is just to graph the ordered pairs. So if you have the equation, you would just plug those in, plug in x's into your function, and get your x and y values. In this case, I labeled it as f of x because it is a function. That's the most common way. But there are some common graphs that you should really know what the general shape looks like without even hesitating. So here are some common graphs that you really should know. We have our linear function here with a slope of 1. Notice it's in slope-intercept form. It has an intercept of 0, and it has a slope of 1. Your basic parabola, y equals x squared, you should know that one. You should also know your basic cubic function, y equals x cubed, your absolute value, which looks like a v. And then you have your higher level ones where you have your basic rational function, which is 1 over x. Your basic square root function, y equals the square root of x. Your basic exponential function, and then your most basic circle, x squared plus y squared equals radius squared. And this would be a circle with the center at 0, 0. At the origin. So these are some common graphs that you should just know automatically. If you don't, you definitely want to take a few notes on these, maybe do a little bit of research. We will be going over these graphs as we go through our course, starting with the most basic ones and then moving into the rational and exponential ones as we move on. So we'll mainly be focusing on this side for now. All right, so when you are graphing a function, first thing you need to do is be able to identify what kind of function it is, and then build your charts for those functions, and then plot the points and graph them. So we are going to do that for these two functions. We have f of x and g of x. Notice I set up a table for both to make your life a little bit easier. So we're just going to get started filling it out. So we're going to start filling out the chart for f of x. Plug in -2, so -2 times 2 is just -4. Do the same thing, -1 times 2 is -2, 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. And then I would go through and plot these points, so -2, -4, 1, 2, 3, 4 would be right here, -1, -2, 0, 0, 1, 2, 2, 4. And then we would draw that line. All right, and then I would repeat this process with g of x. I'll do it in green this time. So plug in -2, so -2 times 2 is 4, -4 minus 3 is -7. Then I'd plug in -1, that'd be -2 minus 3, which is -5. Plug in 0, which would give me -3. Plug in 1, which would be 2 minus 3, which is -1. And then plug in 2, which would be 4 minus 3, which is 1. And then again, repeat. Go through -2, -7 would be a little bit off, so it'd be like right here. And then -1, -5. Let's see, let me count though. 1, 2, 3, 4, 5, 6, 7. Oh, I lied, it would be right there. Let me erase that dot. Oops, thought I had the eraser. There we go. So there's my dot. All right, let's go back to drawing. So -1, -5. So 1, 2, 3, 4, 5. 0, -3. 1, -1, 2, 1. All right, and then draw the line. Whoops, I can't draw a straight line. Please don't judge me on my artistic ability. Okay, so there's my line of g of x, and then the orange one is f of x. Okay, so we've graphed both of the lines. Now it says, how is the graph of g related to the graph of f? So notice these two are parallel lines. They both have the same slope. Their slope is 2, and we can see that in both of the equations right here because they're both in slope-intercept form. And we know that if we took f of x and we shifted every point down 3 spots, that's what g of f would look like. So that shifting we will actually talk about in some future lessons, talking about shifting lines. We would call them transformations, so we will talk about that later. But right now we just wanted you to focus on the fact that they are parallel. They have the same slope. They just have different intercepts. All right, what about if we would do this same exercise, but let's do it with a parabola. So I have f of x equals x squared. So that's our most basic parabola. So again, 0, 0. 1 squared is 1. Negative 1 squared is also 1. 2 squared is 4. Negative 2 squared is also 4. So there's my basic points. Notice they're all perfect squares. That's why I like parabolas, because everything's a perfect square and it's pretty. And notice everything is symmetrical as well, so that's nice. And again, don't judge my drawing. All right, so there is my basic parabola. Then I'm going to come over here for g of x, do the same thing. It's a parabola, but then plus 3. So negative 2 squared is 4. 4 plus 3 is 7. Negative 1 squared is 1. 1 plus 3 is 4. 0 squared is 0. Plus 3 is 3. 1 squared is 1. Plus 3 is 4. And 2 squared is 4 plus 3, which would give me 7. So notice, again, still symmetric. So plot those points. And notice, it looks like I just took that whole parabola, that f of x, and I just shifted it up 3 points. Took each point here and shifted it up 3 points. This point went up 3 points. This point went up 3 points. So very similar to what we saw earlier with the linear. Again, same thing. We took the original graph, shifted it up 3 points. And that is why your y values all went up 3 points from here to here. So there's some basic graphing of that parabola. Again, we're going to hit the heavy hitters that we're going to be using here for the next couple of lessons. Another one that you will see a lot is the square root graph. Square roots, look for perfect squares because you take the square root of x and that will give you what you want. So 0, square root of 0 is just 0. Square root of 1 is 1. Square root of 4 is 2. And the square root of 9 is 3. So I would graph those points, 4, 2, 9, 3. And you get that. It looks like a parabola but sitting on its side. For good reason, and we will talk about why that reason is later. All right, so there's your f of x, and then let's do g of x. I'll do that in red. So square root, if I put in 1, 1 minus 1 is 0. That gives me 0. Square root of 2, 2 minus 1, that'd be the square root of 1, which is 1. Plug in 5, 5 minus 1 is 4, square root of 4 is 2, plug in 10, 10 minus 1 is 9, square root of 9 is 3. So plot those points, 1, 0, 2, 1, 5, 2, 10, 3. And again, notice it looks like I just took that green one and moved it 1 to the right. So it looks like I literally just took each point here and I just moved it over that way. 1 point. Move that one over, move that one over 1 point, move that one over 1 point. 1 point to the right. And like I said, later on in future lessons, we'll talk about why those things are happening because I think that's kind of important to understand the whole big picture. But for right now, we're just going to focus on you plugging in points and graphing these common graphs. All right, one of the first things we really need to look at when we're looking at our graphs is we need to look for intercepts. We talked about the y-intercept a little bit when we were graphing that linear function. That is when the graph hits the y-axis and every point there will be 0, a number. You'll call it lowercase b. But you can also find x-intercepts, and that's anywhere where the graph is going to cross the x-axis. And that is where your number x will be your first coordinate, and then your second coordinate will always be 0. It's important to note that because functions have to pass the vertical line test, they will have at most one y-intercept. They will never have more than one, because if you have 2 y-intercepts, that means that vertical line that is the y-axis would cross the graph more than once, and it wouldn't be a function. But functions can have more than one x-intercept, so we're really going to spend a lot of time graphing x-intercepts and y-intercepts. But for now, I just want you to be able to identify them. So let's get some graphs and identify. All right, so if you look at the graph on the left, I would like you to identify all of the intercepts. So if you want to press pause. All right, welcome back. Let's see how you did. Okay, so when I look at this graph, I see one y-intercept, and that is the point 0, -6. So there's my y-intercept. And then let's look at the x-intercepts. The x-intercepts, I see one here, I see one here, and I see one here. So I have an x-intercept at -3, 0. I have an x-intercept at -1, 0, and I have an x-intercept at 2, 0. So this graph had 4 intercepts, 3 x-intercepts, 1 y-intercept. All right, and then if I look at the graph on the right, repeating the process, I see a y-intercept there of 1, 2, 3, 4. So 0, -4 is my y-intercept. And then I can go look for x-intercepts, and I see an x-intercept right here at 2, 0. And I see another intercept over here at -2, 0. So this graph had 3 intercepts, 2 x-intercepts, and 1 y-intercept. So when you're looking at graphs, that's usually the first thing I look at, is I want to look for those intercepts. Intercepts are points. Otherwise, you have to write out a sentence and say the x-intercepts are 2, -3, -1. So it's up to you how you want to do that. Every textbook, every software package that does math homework will do it differently, but just know those are the 2 official ways. I usually want my students to write them as points, not to write the sentence. So, but instructors may vary. So make sure that you're just doing whatever your instructor asks you to do. All right. Thanks for paying attention, and we're going to take a little break, come back, and talk about more information that we can gather from graphs. So I'll see you then.